Hi everybody, and welcome to exercise 2 on page 40 of the workbook. And let's read this question together. So, a cloth banner 10 meters wide and 5 meters high is placed on the side of a building and left out overnight during a rainstorm. How irresponsible. The next morning, the banner is heavier on the bottom due to gravity's effect on the moisture in the banner. Specifically, the density of this banner at a distance y meters from its top edge is given by rho of y equals 0.5 plus 0.1 y kilograms per meter squared. And they'd like us to find the mass of the wet banner. Okay. Well, first thing to notice here is just kind of the general idea of the situation. So I'm going to just try to draw this. Okay, so we've got this banner. They're giving us the dimensions saying that it's 10 by 5, so let's maybe mark those into our diagram here. And the idea is that there's some water in this banner, but it's settled to the bottom. So you can think of this banner as being heavier at the bottom side than it is at the top side. That's kind of contained in this information here, that our density is actually getting bigger, okay, as we get towards the bottom of the banner. Okay, well, how would we find the mass of the banner? Well, this is similar to the problem that we did with finding the population of the city a while ago. The difficulty is that the density is not constant. It changes depending on where we're at in the banner. Okay, so we'd like to slice this into strips, just like we did with the city. And the question is, how would we slice? We want to slice in such a way that the density of the banner doesn't change very much on the slice. In this case, that means to kind of pick a slice where the distance from the top edge doesn't change very much. So it makes sense in this case to sort of slice in this direction. Okay, so that the distance y from the top edge of the banner to our slice doesn't change very much over the slice that we've got. It stays approximately constant. Okay, and we'll start by trying to come up with an estimate for the mass of just that one strip that we sliced off here. Okay, so I'm going to label that. You'll hear me use the word strip of the banner. I'm just talking about this little slice that we took here. Okay, what would the approximate mass of just that one slice be? Okay, well, we could start by asking, what is the density along that strip? That's going to be given by the density function that they gave us. Okay, and units of that are kilograms per meter squared. Remember, we want to get a mass out of this, so what units would we need to multiply kilograms per meter squared by to get a mass? Okay, we need to multiply by meters squared, so that those meters squared cancel and we just get mass in kilograms. Okay, but meters squared, that's a unit of area. That tells us that what we need to multiply by over here to the right is an area. Okay, and I'm going to maybe remind you of that by just writing area there. Okay, so what would the area of this strip be that we have? Well, we need to take its length times its height, and you can see from the picture that it's 10 meters wide. And what would the height be? Okay, well, we want the height to be a really small distance. Okay, so it's natural to call that dy. Okay, so those two things multiplied together, this times this, is going to give us an idea of the approximate mass of this strip. Okay, and to get the mass of the entire banner, we just need to add up all of those strips from the bottom to the top of this banner. Okay, so we need to integrate. That's how we add stuff up. 0.5 plus 0.1y times 10 dy. And the last question then would be, what are the limits of integration in this case? Okay, well, ask yourself, what is the range of y values as we move from the top to the bottom? Up here at the top, y is equal to 0, and We're going to work our way down to the very bottom. You can see from the picture that because the banner is 5 meters high, we're going to be at 5 meters away from the top. Okay, so our range of our limits are going to be y equals 0 to y equals 5 in this case. Okay, and what's left is to evaluate this integral. So we might start by taking this 10 and just distributing it through. So if we do that, we're going to get 10 times 0.5 is 5. 10 times 0.1 is just 1. So the function we're integrating is 5 plus y. Let's go ahead and get an antiderivative for that. So antiderivative of 5 is 5y. For y is y squared over 2. And then we'll substitute our limits in. Okay, so let's see. If we substitute 5 in for our y's, we're going to get 5 times 5 is 25 plus 5 squared is 25 over 2. And plug in 0 for the lower limits. We're going to get 0 in both cases. So our answer appears to be 25 plus 25 over 2. If you get a decimal for that, that's going to work out to be 37.5. Okay, and the last question would be, what units are we measuring mass in? Okay, well, our work above kind of tells us. We did a unit analysis and figured out that we're going to get kilograms for our units. Okay, and so 37.5 kilograms is the mass of our banner.